let's go to page 61, and this is section 5.6, and this has to do with primes. Prime numbers are the most important integers. Okay, there's a simple reason for this. Every other number can be broken down into a product of primes. For example, 15 can be written as 3 times 5. And so it becomes the product of the prime number 3 and prime number 5. And so this is called a prime factorization. And every number has distinct prime factorization. Okay. And so let's go and do example of how to do the prime factorization. Basically is using the L method. So example 5-9, you have 1, 2, 3, 4, 2, 0. So to find the prime factorization, the best thing to do, just start with 2, the lowest prime number, and just work your way up. So this is even, so you can divide by 2. And it's even again, so you can divide by 2. So now you no longer can divide by 2, so you can try the next prime number 3. Okay, and so you want to test for 3. So 3 plus 8 is 11 plus 10 is 21. So the sum of digits is 21, so you can divide by 3. Okay, now you can try it again. So this is 16. So you cannot divide by 3 anymore. So you go to the next number. Okay, the next prime number would be 5. Again, you only do the prime number. You don't want to do 4 because you're already taken care of by the 2's, right? So you only try the prime number. So next prime number is 5. And this is a 5, so you can divide it by 5. Okay. And so you cannot divide by 5 anymore. So you can try, next one would be 7. See if it divides by 7. So, okay, the technique that we learned earlier. So this one is not. So you cannot divide by 7. So the next prime number would be 11. So 2057. So you do the alternate digits. So this is 7. This is 7. So yeah, so you can divide by 11. So 2057 divided by 11. So it gives you 187. Again, this is so whenever you can divide by a prime number, you want to try that again. You want to test, see if you can divide again. Like there's a repeat, right? So yes, you notice that this is 8. So this can divide by 11 again. Okay, and that's it. And so the 17, so the last, so this would be a prime factorization, this whole thing right over here, okay? Now sometimes people will forget this number, so what you want to do is you want to do it one more time, and so you keep doing it until you get 1. That way you get all the numbers together right over here, so you don't forget this number back here. Because if you just leave a 17 over here, sometimes students have tendency of just doing this and forgetting the 17, right? So this is your prime factorization. So that means 1, 2, 3, 4, 2, 0 is made out of 2 to the 2 times 3 times 5 times 11 squared times 17. So this is your prime factorization. Okay. So that you're done. Okay. Now let's go to example 510. So you want to find the prime factorization of 97. So you want to do the 97. Okay. Now, so 2 does not work. So 3 does not work. 5 does not work. 7 does not work. Okay. 11 does not work. So how far do you go? Okay. Well, what you do is you take the square root of that, because the 97 you take the square root, so it's approximately equal to 10. So by the time you get 10 times 10, we exceed that. So you only have to try all the way up to 10. Okay? So once you get 7 and then the next number is 11, it's just no good already. So that's nothing can factor. So this is a prime number because that's nothing you can take it out. So this is a prime. And so if you read the paragraph below the exercise 5-27, so the question arises, how many prime numbers are there? Okay, the answer is there are infinite number of prime numbers.